Welcome to today's lecture on algebra. I'm Drew Collop. In today's lecture, we're going to review the rules of algebra. With algebra, we're looking to solve an unknown. The unknown must be on one side of the equation and everything else on the other side. Oftentimes, we have to do operations before we can move terms from one side of the equation to the other. It is extremely important you understand the rules of algebra. This is required to solve for equations, and that is mostly what you're going to be doing with math moving forward. Let's look at some of the definitions first to make sure we're speaking the same language. We have sum. This means addition. We have difference. This means subtraction. We have product. We can represent this several ways. We also have the term quotient. This means division. You can also represent this as a number over another number as a fraction. We have a constant. This is a fixed value. It does not change. So for instance, if I had the number 3 in an equation, this value doesn't change. It's always going to be 3 regardless of what the variables are. That brings us to a variable. So a variable, it is an unknown. Normally, we represent the unknown as x, but it can be represented by any letter of the alphabet. When we run out of letters of our standard alphabet, we move to the letters of the Greek alphabet. We have what's known as a coefficient. This is a constant number that's multiplied by the variable. So for instance, I could write 3x. This means 3 times x. So the coefficient here would be that multiplier in front of your variable. We have an expression. This is a mathematical phrase. Very important here. Let me write this down. 3x plus 7y divided by 4. This would be a mathematical expression. So it has constants, it has variables, it has coefficients. But notice what it doesn't have. It's not equal to anything. That's how you know the difference between an expression and an equation. With an expression, we cannot solve it. We can only simplify it and leave it in simplest terms. We can never solve for x or y in this case because it's not equal to anything. We then have a term. A term is separated by an addition or subtraction sign. So as an example here, 3x plus 7y plus 4 times 7 minus x divided by 2. How many terms are here? Well, there is 1, 2, 3, 4 terms. This is one big term. This is also one big term because those values are separated by multiplication and division signs, not addition or subtraction signs. Finally, we have an equation. So this is a statement that two mathematical expressions are equal. For instance, we can have the expression 3x plus 7y, and we can have 23. I can make those two expressions equal, and now I can potentially solve for x and y. So this is all terminology, and you need to understand this terminology. Make sure you review it because we'll be using this throughout this course and in your future math courses as well. Let's examine example 1 and example 2. We have terms, we have constants, we have variables, and we have coefficients. I'd like you now to pause the video and write down each of the terms, each of the constants, each of the variables, and each of the coefficients. Try that now. For example 1, the terms we have. We have 2x over y. That is the first term because it's separated by an addition sign. The next term would be 3y. We have a subtraction sign, x over y squared. We have the addition sign, and then we have 5. So in this mathematical expression, there are 4 terms. How many constants do we have? We only have one constant, 5. What are our variables? We have x and we have y, two unknowns. They can be anything. That's why they're called variables. I can vary it, plug it into the equation, and work it out depending on what I choose for x and what I choose for y. Now, coefficients. Simply here, this is easy one. We have 3 here, but the other ones can be more challenging. This one here, this is actually 2. This one here is 2x over y. If I take those out, I have 2 over 1, which is just equal to 2. So my coefficient here is times 2. Also, I have a coefficient of 1/2. Where do I get the 1/2 from? Right here, I have xy over 2. If I get rid of the coefficients, I have 1/2. So x times y divided by 2 is the same as saying x times y times 1/2. Let's look at example 2. Notice this is not an expression. This is an equation. Why? Because I have 2 expressions equal to each other. This is an equation. What are my terms here? I have 3x squared. I have 8. I have 5x. And then I have right here 2y plus y squared. Notice this 2 would be applied to both of those values. So this is one large term. This would then be separated into 2y and 2y squared. For now, the 2 and the y squared are grouped together. This is one large term. I would then distribute the 2 to both those terms inside the brackets, and then those become 2 separate terms. Constants now, we have only 8 as our constant. Our variables now, we have x and we have y. Now notice there's an x squared and a y squared, but our variable is only x and y. Finally, we have our coefficients. And here we have 3, 5, and we have here a 2. The purpose of this was to make sure you understand the terminology. I will not be asking you this during any sort of assessment. Just make sure you understand. Let's look at some more definitions now. Here we have what's known as a monomial. Mono means one. This is an expression with one term. So for instance, 7x would be a monomial. We then have a binomial. Binomial means 2. This is an expression with 2 terms. So 7x plus 4y would be an example of a binomial. We then also can have a trinomial. Tri means 3. Hopefully you understand that. 7x plus 4y minus 3. So this is an expression with 3 terms. Technically, anything with more than one term can be called a polynomial. Poly means many. Something like 7x plus 4y would be a binomial, also a polynomial. We could add 2z in. That would be a polynomial, also a trinomial. And then we can add in minus 3. And this would make this a polynomial. There are rules for signs. Positive a times positive b is positive ab. And negative a times negative b also makes positive ab. 2 negatives make a positive. On the other side here, all I need is one negative. A times minus b is minus ab. Minus a times positive b is minus ab. And a times b and then negative as the coefficient outside also gives us negative ab. If we have a negative sign outside the brackets, we want to make sure that negative sign is applied to everything inside. So the a and the b are grouped together. The negative sign must be applied to both the a and the b, giving me both a and b. Also, if I'm multiplying a times b, it doesn't matter the order I have them in. I can switch it around to b times a. Doesn't change anything. As an example, 3 times 2 equals 6, and 2 times 3 equals 6. When you're multiplying, it doesn't matter the order they come in. That rule does not apply for division. Let's now talk about simplification. Simplification is collecting like terms. So what is a like term? Like terms have the exact same variable, exactly the same. If they're exactly the same, I add or subtract the coefficients and combine them as a single term. Sometimes you'll need to multiply, divide, distribute, expand to get a final answer that looks simpler. Let's now look at some examples of adding and subtracting values with like terms. I have 3x squared plus 3xy minus 4y minus 2xy plus 6x. Remember, like terms have exactly the same variable. So here I have 3x squared, and here I have 6x squared. The variable is x squared, so those are exactly the same. Other ones I have here, 3xy and 2xy. They have the exact same variables, x and y. And 4y, the y is on its own. So what I can do is I can collect like terms together. This would give me 3x plus 6x, 9x squared. I can then do 3xy minus 2xy, 3 minus 2 is 1, plus 1xy. And finally, I can take this variable here and put that down right there. You can see we've collected like terms. Instead of having 5 terms at the beginning, now we only have 3 terms. Unfortunately, this is as far as we can take this expression unless we knew what x and y was. I'd like you to try an example on your own. Collect like terms. Remember, like terms have to have exactly the same variables. Let's take it up. We have 4a. I see no other values with a. We have b squared. We have b squared. And we have ab. And we have BA. Remember, when you're multiplying, it doesn't matter the order they come in. So A times B is the same as B times A. So those are technically like terms. Let's combine these together. 4A remains as is. We then examine these two. 5 plus 2 is 7, B squared. And then lastly here, we have these two here. Minus 3 minus 5 is minus 8, AB. We can write it as AB or BA. So hopefully you understand now what like terms are and how to combine them together. Remember, they must have exactly the same variables. X and x squared are not exactly the same. Now let's examine multiplying monomials. Remember, monomials are a single term. So here we have 2 monomials, 2x squared and 7x. We're multiplying them together. So what we do is we multiply the coefficients, 2 times 7, and we multiply the variables, x squared times x. When we do that, 2 times 7 is 14. Now remember our exponent laws here. We have 2 exponents with the same base. Remember, you don't see the exponent there, so you assume it's a 1. What happens when we multiply 2 exponents with the same base? We add the exponents together. So x cubed becomes the answer there. Try the next one on your own. Let's take it up. So we have minus 4 times 3. We have a squared times a, and we have b times b cubed. Combine them all together. Minus 4 times 3 is minus 12. A cubed, b to the exponent 4. Final answer. Not too challenging. Let's see what happens now when we divide monomials. What we do is we divide the coefficients and we divide the variables. So here we get 20 divided by negative 5, multiply by x to the 4 divided by x squared, and then we get y cubed divided by y squared. If it helps you, you can also write it in this fashion. 20x to the 4 y cubed divided by minus 5x squared y squared. These two things mean the same thing. Why? Because these are two separate terms. Those whole things are terms. Now we can examine the coefficients, the x variables, and the y variables. What we can do, we can simplify. What's 20 divided by minus 5? That's going to be minus 4. We have x to the 4 divided by x squared. When we have 2 exponents with the same base, and we're dividing them, we subtract those. So x squared. Lastly here, we have the same deal here. Y, 3 minus 2 is 1. 4y to the 1. So in this manner, it doesn't matter how you write it. You can write it as a fraction or you can write it in this manner here. I happen to prefer the fraction method because I can line up the coefficients and the variables. Why don't you try example 8 on your own now? Let's take it up. So here we have 6x squared y cubed divided by 2x cubed y squared. Let's combine my coefficients. This gives me 6 divided by 2 is 3. Let's combine my x values here. I have x squared divided by x cubed, so 2 minus 3 is 3 to the minus 1. And then lastly here, let's combine the y variables. Y cubed divided by y squared, 3 minus 2 is positive 1. What I would recommend, if you have negative exponents, move them to the opposite side of the fraction to make them positive. This would give me 3y over x. That means the same thing. Let's look at some more examples here. Here we have brackets, 3 plus y, and we have x on the outside. So this x value must be distributed to both those values on the inside. When I do that, I have 3x plus xy divided by x. Now notice here, I've grouped the 3 and the y together. So I must maintain the brackets to indicate I must add those first before I do division. Otherwise, the division takes priority and I must divide first. Because the 3x plus xy is grouped together, I can convert that into a fraction. Now be careful. You can cancel terms out here. Why is that? Because there's an x in the bottom and every term, very important, every term on the top also has an x. So if that's the case, I can cancel out a single x, and this would give me 3 plus y over 1, which is just 3 plus y. Be careful. Here is a technique you can use. Let me show you now. 3x plus x over y divided by x. We call this a common factor between those two terms. They both have an x in them. So what I can do is I can take it out. I get 3 plus y over x. Notice that's what we had at the start. So right from the start, I can turn that into x, 3 plus y over x. And then you can see I have an x. It's outside the brackets applied to everything. I have an x here. So then I can cancel those out. So if you can see a common factor you can take out, and you have that same common factor on the bottom, you can simplify by canceling out quite quickly. I would like you to try example 10 on your own now. Make sure you cancel out where applicable. Let's take that up. You can see we have one term divided by another term, so I can rewrite that as x squared plus xy divided by xy. Let's pull out a common factor. You can see I have an x on the bottom and I have an x on the top. I can only pull one x out. So I take an x out. This gives me x plus y divided by xy. Because I have the same term on the top and the bottom, those cancel each other out. This then gives me as x plus y over y. Now be careful. What students will want to do here, they'll say, well, I have a y and a y here, and those cancel each other out. Incorrect. Why can't you do that? Because this term right here does not have a y in it. In order to cancel a variable out from a fraction, every single term has to have that variable. The x does not have a y, therefore, you should not do this. So I'm going to write no right here. This final answer should just be x plus y over y. Until we know what x and what y is, there's nothing else we can do further. I'd like you to give 11 and 12 a try now. Pause your video, give it a try. Let's work out 11. X squared plus y cubed over x, y. Remember, we have a term divided by another term. That's how we can set this up as a fraction. What can we do here? Absolutely nothing. I have an x here and an x here, but I have no x here, so there's no common factor there. I have a y here and a y here, but no y here. So there's nothing we can do to cancel each other out. So in this case here, this is just the final answer. X squared plus y cubed over xy. Nothing we can do. Example 12 now. 2x squared plus 4xyz divided by 2x cubed z. Let's see what we can do here. Let's look at our coefficients. I have a 2, I have a 2, and I have a 4. I'd like to cancel a 2 out. I can pull a common factor of 2 out of the top. Let's pull out that common factor of 2. On the top, we have a 2 on the bottom. But what else can we pull out? Is there anything else we can pull out? Well, here I have a z here and I have a z here, but I have no z here. Can't do anything with the z. What else do I have? I have an x, I have an x, and I have an x. But this one only is an x with an exponent 1 on it, so I can only pull a single x out. So let's pull the x out of that one. If I pull 2x away from x squared, what's left? Just x. If I pull a 2x out of 4xyz, here I get plus 2yz. Notice, if I was to distribute this here and here, I would end up getting what I started with. Let's pull that x out of the bottom, and that leaves me with x squared z. You can see I have the same term on the top and the bottom. They cancel each other out, leaving me with x plus 2yz divided by x squared z. Final answer. When simplifying fractions, make sure you have exactly the same variables in every single term on the top and the bottom. If that does not exist in every single term, you cannot cancel it out. We touched on this briefly already during this lecture, but let's formalize it. Let's talk about distribution. So this is when I have a monomial multiplied by a polynomial. So we see numbers in brackets, and we see there is a value outside the brackets. It's multiplied, so I must distribute this to all terms inside. To make sure it goes to all terms, I would encourage you to write these little arrows. 2x plus 2y. Final answer. Next one's pretty easy as well. We distribute x to this term and x to that term, giving me x squared plus xy. The reason why I encourage you to put these arrows in is that I want to make sure you distribute it to every single value inside the brackets. It's easy for these ones because there's only 2, but later on it may get more challenging. Don't skip steps, put those arrows in. Give 15 and 16 a try on your own. I want you to distribute the value outside the brackets and then combine that with your knowledge of collecting like terms. Try that now. Let's take them up. So in example 15, I have 2x outside the brackets. Let's distribute it to the x, to the y, and to the minus 3y squared. This will then give me 2x squared plus 2xy minus 6xy squared. I've tried to color code them for you so you see where they're coming from. Make sure you distribute to all terms inside. Let's do the same thing down below. Let's distribute here. First, we get 4x, and then here, plus 12y, then to this one, minus 4xy. Move on to the next grouping here, minus x times 3y, minus 3xy, and then lastly here, minus x times minus 4 gives me positive 4x. So now I've got rid of the brackets. Let's see if we can collect like terms. Here I have a 4x, and I have a 4x. Here I have a y, and that's the only y I have. And here I have an xy and an xy. So I can collect some of those terms together, the like terms. 4 plus 4 is 8, giving me 8x. We have plus 12y. Minus 4 minus 3 is minus 7xy. Final answer. When you have a large expression like this with a coefficient outside the brackets, make sure you distribute it to all values inside the brackets and then simplify where possible. So that was examining when we had a monomial multiplied by a polynomial. So the monomial was outside the brackets and a polynomial was inside the brackets. Let's examine now when we have a binomial multiplied by another binomial. So you can see here we have a binomial multiplied by another binomial. That's what that means when you don't see a sign in between two brackets. It means multiplied by. Oftentimes in math, there are little acronyms to help you remember how to do your work. FOIL is the acronym when we're multiplying one binomial by another binomial. What it stands for is first, outside, inside, last. Let's now apply this to this binomial. You can see here, this grouping and this grouping, they're multiplied together. So what happens is the first values have to be multiplied together, and then the outside values. And then we must combine together the inside values, and then we combine together the last values. So let me try and underline these. We have first, outside, inside, and we have last. Let's see what that's equal to. I'll try and color code it for you. 3 times 3 is 9. 3 times minus 2x is minus 6x. X times 3 is 3x. And finally, x times minus 2x is minus 2x squared. Can we collect like terms? We sure can. These are both have a value of x on them. This gives me 9. Minus 6 plus 3 is minus 3x minus 2x squared. You can leave it like that. I don't care how it's expressed in this class. If you move to other math classes, other professors, they prefer it to be in order of highest degree term to lowest, so they would want it as minus 2x minus 3x plus 9. Those two things mean the same thing. Oftentimes, some instructors prefer it written like this. Again, in this class, I don't really care. Try example 18 on your own right now. Expand and then simplify. Let's take it up. So let's do FOIL. First, 12x squared. Outside, minus 9xy. Inside, plus 4xy. And then we have last, minus 3y squared. We then have 2x squared minus 4y squared. So we've expanded out those two binomials by using FOIL, and now we're going to collect like terms. We have an x squared, we have an x squared. Here we have an xy, xy, and that's it. And here we have a y squared and a y squared. Let's combine those down on the next line. We collect like terms. 12x squared plus 2x squared is 14x squared. Now, when you have a lot of numbers like this, it's sometimes helpful to cross them off as you go. Just going to put lines through there to indicate that I have brought those down. Next up, I have xy's. Minus 9 plus 4 is going to be minus 5 xy. And again, I'm just going to put a line through those to indicate that I have moved them down to the next line. And then lastly, we have y squareds. Minus 3 minus 4 minus 7y squared. And we're going to cross those off. When you have a lot of terms you have to collect, you can sometimes miss one. If you put a little line through the values you've already moved down, then you won't miss one. Final answer. This is an expression. It's not equal to anything, so we cannot solve it. Example 19. I want you to try this on your own. I want to see what you do with this. We've discussed this already in previous lectures. Let's see if you make the same mistake. Give this a try now. Let's take it up. 3x minus 2y squared. So I just distribute this here and here, right? And I get 9x squared minus 4y squared, right? Wrong. Do not do that. This is a common mistake. You can't do that. Why can't you do that? Because these are two separate terms. These are two terms. You cannot do that. So please don't fall into that trap. Remember what this is equal to. This is 3x minus 2y times 3x minus 2y. The brackets are around the 3x and the minus 2y. Therefore, that whole thing is your base. So I take that and I multiply by itself. I'm now going to get rid of the brackets by applying FOIL. 3x times 3x is 9x squared. first outside, I have 3x times minus 2y minus 6xy. I do inside, minus 2y times 3x is minus 6xy. And then last, minus 2y times minus 2y is positive 4y squared. Let's collect like terms right here. 9x squared minus 12xy plus 4y squared. That is the final answer. You can see that this one here is missing this value altogether. Also, I made it negative. Remember, two negatives make a positive, so let's put a positive sign in there. But you can see why this does not work out, because those are two separate terms. If you just distribute the squared to both the 3x and the minus 2y and you work that out, you've missed completely the minus 12xy. Make sure if there are multiple terms inside the brackets, don't distribute the exponent. Now we're going to apply that same knowledge to something a little bit more challenging. We had a binomial multiplied by a binomial. Now let's have a polynomial multiplied by a polynomial. Specifically here we have a trinomial multiplied by a trinomial. But the same rules apply. All the terms must be distributed to every term on the other side. So the x must go to the a and the b and the c. The y must go to the a, the b, and the c. And the z must go to the a, the b, and the c. So we distribute the x. You can see we have ax, bx, cx. We distribute the y. We have ay, by, cy. And then we distribute the z. We have az, bz, cz. Can we collect any like terms here? We cannot. This is now the final answer. Let's try 20 together. Let's first distribute the 2x here, here, and here. What I get now is I get 2x squared plus 4xy minus 4x. We'll now distribute the 3y plus 3xy plus 6y squared minus 6y. Lastly, we'll distribute the 9, giving me 9x plus 18y minus 18. Now let's see if we have any like terms here. I have an x squared. I have no other x squareds. So let's bring that down. And we'll just put a line through that one. Let's now examine our xy's. xy, xy, and that's it. Collect those terms together, plus 7 xy. Cross those out. Let's now look at our x's now. X and x. Combine those together. Minus 4 plus 9 is plus 5x. Let's look at our y squareds. There's only one y squared. Next up, our y's. We have two y's here. Minus 6 plus 18 plus. Those are done. And then we have one constant, minus 18. And that's as far as we can take it. You can see we've taken something very simple. We've made it a bit larger, and it gets more complex. I'd like you to try example 21 on your own. A binomial multiplied by a polynomial. Make sure you distribute to all values inside those brackets. So the 2 has to go to all four terms. 4x to the 4 minus 2x cubed plus 4x squared plus 2x. Next up, we have to distribute a positive one. Distributing a positive one is very easy. We just copy down what's there. Now let's collect like terms. X to the 4, I only have one of those. X cubed, I got two of those. Minus 2x cubed plus 2x cubed, well, that's 0x cubed. So I can cross those off, and there's nothing on the next line. It's just 0. We have x squared. I have two of those. 4 minus 1. We combine like terms here. 4x squared minus 1x squared gives me plus 3x squared. Cross those off. I have a 2x and a 2x. Combine those together gives me 4x. Cross those off, and then we have a coefficient left of +1. And when you're done, you should see all values are crossed off. If not, you missed one, go back and correct it. And you can see this is now our final answer right here. We've expanded out, distributing all those values in the binomial to the polynomial, and then we collect like terms. Now you can take everything you learned today about distributing monomials, binomials, and polynomials, and then simplifying by collecting like terms. But now we're going to do it together with BEDMAS. So I'd like you to try these on your own. Try example 22, 23, 24, and 25. 25, you're going to need a fair bit of space, I think, to answer that one. So make sure you give yourself enough. So give these a try, and then I'll take them up. Let's take them up. First of all, let's distribute here and here. 2a squared plus 2ab. Next up, we're distributing the minus 5b. Minus 5ab minus 5b squared. We've now dropped the brackets. We've distributed those monomials into the binomials. Now we collect like terms. I have an a squared, I have an ab, and I have a b squared. So I can combine these two together only, giving me 2a squared. 2 minus 5 is minus 3ab minus 5b squared. Final answer. That's as far as you can take it. Again, this is an expression. We cannot solve this because it's not equal to anything. I could, if I knew what a or b was, I could combine them and make one term if I knew both a and b. Example 23 now. Let's take that up. Distribute here and here. 12x squared plus 8xy minus xy. And then here, let's just make sure we don't mess up, we're going to square the x plus 3y and write that down. 12x squared plus 8xy minus xy. First, we'll distribute the x to both terms. And then we'll distribute the 3y to both terms. Now, we've got rid of the brackets. Let's now collect like terms. I have an x squared, I have an x squared. Remember, you don't see the coefficient here, so you assume it is a 1. So we have 12 plus 1 is 13. Cross those off. xy, 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 xy. So I have 4 like terms here. 8 minus 1 is 7. Plus 3 is 10. Plus 3 is 13. 13 xy. And I can cross off all 4 of those. And then lastly, I just have the y squared plus 9y squared. And I cross that off. Final answer. Let's take up 24. Remember to follow your rules of BEDMAS when necessary. Here we have 9a. We distribute the minus 2 here and here. Minus 6 minus 8a. We then distribute the minus 2a here and here. Minus 6a plus 2ab. And then do not distribute this one. Why not? Because that's multiplication. What do we do before multiplication in terms of BEDMAS? We do exponents. So this would give me plus a, 1 plus b, 1 plus b. Now, technically you could distribute this, but you distribute to only one of those, not both of them. But I would encourage you not to do that. What I would like you to do is just FOIL those first and then distribute the a. Now that I've FOILed the 1 plus b, now distribute the a to all terms inside. Again, I encourage you to do this because students try and cut corners. I've seen this before, and they mess it up. Let's now collect like terms. I have a, 4 terms. 9 minus 8 is 1, minus 6 is minus 5, plus 1 is minus 4. We'll cross those off. Next up, we have our constant. Any other constant? There are no other constants, so we'll just write that as minus 6. We'll cross that off. Then we have AB, AB, and AB. We have 3 of them. 2 plus 1 is 4AB. Cross those off. And then lastly, we just have AB squared plus AB squared. And that crosses off. So notice, AB squared is not the same as AB. Very important. And here we have the final answer. That whole thing boils down to those 4 terms. Let's work through example 25. This is a challenging one. Now notice, I have all of that is one big grouping. Those are brackets combining those together, and that 2 is multiplied there. I have a division sign. I have brackets combining all those together. So because I've grouped those all together, I can rewrite that now as 2a plus 3ab squared. Divide that by 3a minus a 5 plus 1b. Remember, I can do that because these have been grouped together. Now let's work that out. Let's FOIL this. 2a plus 3ab, a plus 3ab on the top. On the bottom here, let's work on that one. Distribute that there and there. 3a minus 5a minus ab. Now let's FOIL the top. First, outside, 2a squared plus 3a squared b. And then we do inside, and we do the last. Plus 3a squared b plus 9a squared b squared all over. We can collect like terms here. I have an a and an a. Can do that on the next line. Minus 2a minus ab. Now that I get rid of the binomial squared, now I can distribute the 2 to all terms inside. Make sure you distribute it to all of them inside. 2a squared plus 6a squared b plus 6a squared b plus 18a squared b squared, all divided by minus 2a minus b. Let's collect like terms on the top. I have an a squared b and an a squared b. Combine those together. 2a squared plus 12a squared b plus 18a squared b squared, all divided by minus 2a minus b. Now let's see what we can do. Can we cancel anything out? Remember, all terms must have that same value. I look at this and I can see all terms have an a in them. So let's pull out a common factor of a from each of those terms. I'm going to take an a out of the top. I'm going to take an a out of the bottom. Take an a out of this one. What do I have left? I have just 2a, right? A times 2a is 2a squared. I take an a out of the next one here. I have 12ab. And then take an a out of this one here, and I have left 18ab squared. On the bottom here, I take the a out. I'm left with minus 2 minus b. Because I have the same on the top and the bottom, they can cancel each other out. And now I'm left with 2a plus 12ab plus 18ab squared divided by minus 2 minus b. Now you can see here, I have 2, 12, and 18. It would be nice if I can pull out a common factor of 2 to try and simplify that down. Let's look at the bottom now. This one has a 2, but this one does not. So unfortunately, we cannot take it any further. There's your final answer. So remember, all terms must have that same variable if you want to cancel it out. All terms in the numerator and all terms in the denominator. If you only take away one message from this lecture, it is that. We're going to examine one more thing before this lecture is over with. Let's look at a binomial raised to a power. Here we have a binomial, a plus b, and here's our exponent. Our exponent on this is 0. Anything raised to the exponent 0 is going to be 1. Now let's look at a plus b to the exponent 1. Well, anything raised to the exponent 1, it doesn't change anything, so this is just going to be a plus b. What about the next one? A plus b squared. A plus b times a plus b. We FOIL it. A squared plus ab plus ab plus b squared gives me a squared plus 2ab plus b squared. Hopefully you see where this is going. We had 0, 1, 2. Now let's go to 3. And 4. A plus b cubed. This is a plus b times a plus b times a plus b. Now up above, we already did this. This whole thing is this. So we can kind of cheat here. And we can just copy that down. And then we multiply that times a plus b. Doesn't matter the order you do it in. I'm going to work in reverse here. I'm going to apply the a to all these values here. A cubed plus 2a squared b plus ab squared. And then I'm going to distribute the b to all values inside. This is plus a squared b plus 2ab squared plus b cubed. Collect like terms now. I have like terms a squared b, and I have ab squared. So in the next line, I can collect those like terms. A cubed plus 3a squared b plus 3ab squared plus b cubed. Let's do it again. This time, a plus b to the 4. Remember that what that's equal to now. This is a plus b times a plus b times a plus b times a plus b. Now let's cheat again. All of this is all of that. So let's just replace that, substitute in a cubed plus 3a squared b plus 3ab squared plus b cubed. All of that multiplied by a plus b. Let's distribute the a now. A to the 4 plus 3a cubed b plus 3a squared b squared plus ab cubed. Let's distribute the b now. Plus a cubed b plus 3a squared b squared. Running out of space here. Plus 3ab cubed plus b to the exponent 4. Let's collect like terms. A cubed b, a cubed b. A squared b squared, a squared b squared. AB cubed, AB cubed. Combine those together. A to the 4 plus, cross that off now that I've brought it down. Here I have 3 plus 1 is 4. A cubed b. We cross those off. Next up, we have our a squared b squared. I have 3 plus 3. It's going to be 6. A squared b squared. Cross those off. Here I have my ab cubed plus 4ab cubed. Cross those off. And then lastly, I have b to the exponent 4. That right there is the final answer. You can see this is getting more challenging. Let's see what happens when we do a plus b to the exponent 5. What is that equal to? We're not going to do that. What if I had a plus b to the exponent 90? You're definitely not going to want to do that. As you can see, as the mathematical operations get bigger, you can do it. It just takes a lot of effort. Thankfully, there are some patterns people have observed, and there are easier ways to go about this. That is the topic of the next lecture. In today's lecture, we've reviewed many of the terms used in algebra. We've talked about the difference between an expression and an equation. We've talked about collecting like terms and distribution. In the next lecture, we'll examine what's called Pascal's triangle to solve something like this much more simply. That's all for today. Until next time.